We're going to take a quick look at a couple of important new features in Watson OpenScale, which is the ML Model Quality Monitoring Facility that's in Cloud Pak for Data. First up is our new ability to understand indirect bias. As you can see here with our fairness detection metrics, we're able to put a number to the degree that a model provides a favorable outcome to scoring events for groups in the monitored attributes. For this candidate hiring recommendation model, we can see OpenScale has calculated a fairness score of only 75%, which has set off an alert. What this means is that the model scored women, which is the monitored group here, with favorable outcomes 13% of the time, while if the model scored these events perfectly equally, we'd see favorable outcomes at just over 17% of the time. As a quick aside, the user interface design has improved a great deal this year, as it's much easier for users to understand the severity of a bias problem and the numbers behind it. At the same time, users can click on some of the little tooltips here to get a sense of the math behind the numbers. But the biggest addition in the fairness dialog is the indirect bias indicator, which we can see here below the fairness dashboard. So while the person responsible for the risk management of a model needs to select the attributes to monitor for fairness, in this case gender, it can be difficult to understand how a model actually exhibits gender bias if that model isn't used in the model scoring. A common cause for bias to creep into model scoring is when you've got other features that are correlated to the one that you're monitoring. For example, here we can see that the salary expectation field is correlated meaningfully enough to gender that it's likely the source of the bias, resulting in fewer favorable outcomes for women applying for jobs. With this information, data scientists can either remove this feature from the training data set to train a new model, or they can work to debias the training data in a more targeted way. We've already made it possible for organizations to identify bias in their models before they deploy them. Now, with indirect bias detection, we've made it much easier for data scientists to actually pinpoint sources of how a bias can creep into their models. The second new feature is our ability to provide even better explanations on how a machine learning model arrives at its conclusions. Here, we see the explanation for a scoring event for a model that provides recommendations on hiring employee candidates. Right away, we see some of the design improvements in the user interface, as we can now easily understand which features had the most weight for this particular scoring event. If we click on the new Inspect tab, we get to drill into these explanations and do some what-if analysis. On the far right, you can see the biggest adjustment for an individual feature that would result in a change in the predicted outcome. In addition, and this is where the meat is in this new feature, you can feed your model sample scenarios to see how it responds to real-life or theoretical situations. This means of experimenting is helpful for a number of possibilities. For example, with well-trained models, this is the kind of what-if, and this kind of what-if analysis can be a really useful prediction tool. This is also a really good means of testing a model that's under development against known use case and some variations. Both of these new features represent how our design and development organizations have taken work from IBM research and implemented it so that it goes from being a set of really interesting science projects to some product features with real business value.